Hi, my name is Julia Boes. I'm a senior member of technical staff at Oracle's Java Platform Group. And for the next 30 minutes or so, I'm going to talk about the simple web server. That's the minimal static file server that we added to JDK 18. Before diving in, I show you this safe harbor statement for the usual reasons. You can have a quick look at it. All right, so what am I going to talk about? I'm going to start with an overview of what is the simple web server, how did it come to life, and why did we decide to add it to the JDK? After that, I'm going to dive into the use cases. So what can you do with the simple web server? And then I'm going to talk about a description. So what can the web server do for you? How is it specified? And how can you configure it? And after that, I'm going to talk about the two aspects of the simple web server. There is the command line tool on the one hand. So how can you use it? How is it configured? And then on the other hand, we have a few new API points. I'm going to talk to you about some interesting use cases and what that looks like. Okay, let's get started. The summary of the simple web server is that it's a minimal HTTP static file server. And it's really nothing more than that. It serves only a single directory hierarchy, and it only serves static files. It's important to understand that it's not a feature-rich server because there's far better alternatives, whether that's server frameworks or production servers. And the minimal design of the simple web server is purposeful to avoid any confusion with those alternatives. In terms of history, the simple web server comes with JDK 18. It was added with JEP 408 and work completed in January of this year, so 2022. The API is localized in the JDK HTTP server module. In that module, you find a com/sunnet HTTP server package, and that package has been included since JDK 9, so since around 2016, and it's officially supported. In terms of goals, there's three ones. We wanted the simple web server to be as easy as possible to use, and that's the reason for its minimal functionality. Behind that, there's a wider goal, and that is to make the JDK more accessible with an out-of-the-box tool, where you can really just use one command on the command line and you're ready to go. And then while we have this command line tool, which is at the focus of this project, we also have an API that complements it and that allows you to use the components of the simple server and to customize them even further. So with that, let's look at an example of jwebserver, which is the command line tool. Before we go into the specifications and what you can do with it, I wanted you to have a look at an example so that you know what it looks like. So with this command, jwebserver, you start the simple server with default configuration, with default options. So once it starts successfully, you can see that the server prints a message to system out, and it lists the local address. In this case here, that's the loopback address. And it also gives you the absolute path of the directory that is served. So in this case, that's the CWD current working directory. I also want to show you an example of the API point. For all the API examples in this presentation, I'm using JShell, which is Java's REPL shell. And it really just shows you with how little lines of code you can use the API. So the package that you import is com/sunnet HTTP server. I already mentioned that. And then here we're using one of the three static methods that we added. It's called create file server. And that method returns a fully configured server instance that you can then start with server start. So now that you've seen two examples of the command line tool and the API, you might wonder, what can I use this for? So let's look at the use cases. I guess everyone has served a page on the web before. It's a bit of a ritual for developers. And a tool with such basic server functionality really comes in handy in all sorts of scenarios. A lot of them are in the realm of education and informal tasks. And the three that I list here are probably the most prominent ones. So we start with web development testing. You often want a local testing server to simulate a client server setup to send requests and responses back and forth and test your application. It can also be handy in the case of web services or web application testing. What happens here is that you commonly have RESTful URLs that map to functions. So for example, /app/browse might map to a browse function. So while the implementation of those services is still work in progress, you might want to use static files as API stubs to test the system. And then lastly, browsing and sharing of files across systems. So let's say you have a remote server and you want to search a directory on that server from your local machine. So for these and for all kinds of other scenarios, the simple web server bypasses a lot of the ceremony that typically comes with frameworks and also with our existing JDK HTTP server API. So instead of digging through the configuration details or getting to know the API, you can really just focus on the task at hand. Okay, with that, let's look at the specifications of the simple web server. So what can it do? I already mentioned this. The server only serves a single directory hierarchy and only serves static files. So when a request comes in, the mapping happens as follows. There's three options. If the requested resource is a file, then the content of that file is served. If the requested resource is a directory that contains an index file, then the content of that index file is served. And then lastly, in any other cases, the directory listing is returned in HTML and it lists the files and subdirectories of the directory. In terms of request methods, only head and get requests are supported. For any other requests, we return either 501 not implemented or 405 not allowed response. And then lastly, the simple server only supports HTTP 1.1. We don't support HTTP 2, and we also don't support HTTPS. Sorry. So these are the specifications for both the command line tool and the server instance that is returned by the API point. They both use the same server implementation under the hood. All right, with that, let's look at the command line tool. So you might remember this example from earlier. It starts the simple web server on the command line with default options. Now you might wonder, what are the options? And for that, you can either use the man page of the jwebserver with this command. That gives you a description of the usage, the options, configuration. Or you can use the --help or -h flag to get this output. And this is just a little summary of the different options that I use now to walk you through this. So from top to bottom, the first option that you have is the bind address. The default bind address is the loopback address, as you can see here, but you can specify any available bind address, including the wildcard. Next up, we have the directory. This defaults to the current working directory, but again, you can specify others. Then we have the output flag. That is really just some sort of logging to the command line. There's 3 different levels, and I'll show you an example later on to see what that looks like in more detail. Basically, you can either turn it off completely with none, you have the default output level info, or you have a very verbose output. Then the next option is the port. The default is 8000, but you can listen to other ports as well. Then we have this -help flag that you have seen here already. And then we give you some version information as well. And then lastly, we tell you how to stop the server, because once started successfully, it runs until it's stopped. So you do want to use Control-C if you want to stop the server. Okay, let's look at a few examples on how you can further configure this. By default, I said it already, the server binds to the loopback address and port 8000. This can be changed with the -B and -P options. So in the first example here, you can see that we bind to all interfaces. I should note, however, that this really makes the web server accessible to all hosts on the network, so please use with caution. Then in the next example, we specify a different port, 9000, very straightforward. And then the last example just shows you what this logging output looks like. If you choose the default level info, for each request, you see this line. So it includes from left to right the remote host address. In this case, it's the loopback. Then in brackets, you have the date. Then in quotation marks, you see the request line. And then you have the status code as well. If you choose output level none, there's none of this output. If you choose verbose, additionally, you also get all the request and response headers, and you get the absolute path of the resource requested. Yeah, and that's it. So it's a minimal yet configurable server so that it serves most use cases. However, if you do want to go further than this, we really recommend having a look at the API that we added alongside the command line tool. And that's what we're going to look at now. So as I was saying, the command line tool is very straightforward, but what if you want to use the components of that server in existing code? Or what if you want to further customize the behavior of the handler? So we wanted to bridge the gap between the kind of simplicity of the command line tool and the write-it-yourself approach of the existing API. So we defined a few API points for server creation, component creation, and customized request handling. To better understand those new API points, I briefly want to describe the key abstractions of the existing API in JDK HTTP server, just for you to understand how the new bits fit in. So in this diagram here, you can see the server in the middle. That's the entity that listens for incoming TCP connections. On the right-hand side, you have a client. That's what's sending requests and receives responses. Requests and responses can also be described as an exchange, so one request and one response pair. And then on the left, you have a handler. A handler is the entity that is at the core of the request handling. So it's registered with a server. It can be one or many. And that's where the actual handling of the request takes place. And then lastly, on the very left, we have a filter. They are similar to a handler, but they can be put either before or after the handler processes a request. So it's pre or post processing. So when a request comes in, what happens? So how does the server dispatch a request? For this, we have another abstraction, and it's called context. A context is really just a mapping between a root URI path and a handler. So for example, browse /browse URI path and a handler for browsing files. So as I said, the server can have several handlers registered, and it dispatches a request that comes in based on the context. So when a request comes in, the server checks the context and chooses the handler with a matching context. The handler then is the callback that handles the incoming request. And a filter, let's say a post-processing filter, has a look at the request after the handler has handled it. So filters are commonly used for, in case of post-processing, for logging, for example. Now, in the old API, you had to do all of this yourself. Write the handler, write the filter, configure the server, add the handler to the server, register the filter with the server. So all this can be a bit tedious and might not be necessary for really simple tasks like a static file server. So for this, or for our new API now, we focused on the relevant components for the simple web server, which is the server to dispatch requests, then the handler to process them, and then a filter to do post-processing for logging. So these three components is what we pulled out into the new simple web server API and added 3 static methods to make them available. These methods were added to a new class called simple file server. You can see it here in the example. And it naturally translates the components of the command line tool server into the API. So the first method up is create file server, and that returns you a minimal yet customized static file server. It has three parameters. You can pass it a bind address and a port. You can pass it the root directory and an output level, in this case for Boes. And then the method returns you a fully initialized server that you can just start with server start. Then as a second method for a handler, we have create file handler. That returns you a customized file handler that you can add to an existing server. You pass it the root directory that you want to serve. And then on the second line here, you actually see a nice other new addition to the API, which is an overloaded create method. So previously you had to create the server and then add a context and add a handler. Now you can do it all in one go with initialization. And you get the server ready with a context and a handler and can start it from there. And then the last method in simple file server is create output filter. That static method returns a filter for logging that you can again add to an existing server or create or add during creation. You pass it an output stream and an output level. And here on the second line, you see the server now has a handler and some context, and the filter is a post-processing filter that logs a request after this some handler instance has handled it. So with these three static methods, it's easy to create and further customize the components of the simple web server. And now that it is so easy to retrieve the components, we realized that we also wanted to enhance the composability, in particular of handler instances who hold the core logic of request handling. So the question came up, how can we provide ways to combine and further customize handlers in a convenient fashion? For this, we have added two little bits, and I show you the first one on this slide and then the next one on the coming slide. So for enhanced request handling, the handler is really at the core of the show here. And we added two methods to a helper class, HTTP handlers. The first one is called .off. It's really just a factory for canned response handlers. And the second one is handler else. So I'll walk you through this now with the example. So the handlers off method on the second line here returns a canned response handler. So that's a handler with a fixed response state. In our case, that's the status code of 200, a set of headers, and then the body of some JSON file. And this handler is then called JSON handler. On the next line, then you can see another canned response handler that always returns a 405, set of headers, and an empty body. And now this other method, handler else, is kind of like a combinational handler. It takes two handlers and a condition, and then it determines based on the condition whether handler A or handler B handles the request. So in this example here, you can see that we have defined a predicate is get. That is really just a true-false check if the request method is get or not. So now this handler else handler, when a request comes in, checks the predicate. If the request method is get, the JSON handler gets to handle the request, and otherwise it's the not allowed handler. So these two methods, both for creating canned response handlers and then for combining handlers, make it really easy to kind of write your own custom logic of request handling. Then as a next method, we have filter adapt request, and that's for checking request state, checking the request state and potentially adapting it as well. This method shines in the context of testing, kind of weird or unusual edge cases and different debugging scenarios. So the filter that filter adapt request returns is a pre-processing filter. And I introduced you to that concept before already. So it's a filter that gets to inspect and potentially handle, adapt the request before the handler sees it. So the request state that can be inspected is the request URI, the request method, and the request headers. And as you can see in this example here, the filter adapt method always adds a header, a foo header to a request. Now, when the sum handler that is passed to the server in the second line gets to see the request, the foo header has already been added by the filter. So what this helps with is it enables the straightforward adaptation and extension of existing handlers. So now that you've seen all the new API points, you might wonder, how can I use this, or where exactly can this be helpful? So I want to continue with use cases, and in this time around, I focus more on the API than the command line tool. So the use cases are manifold. The first one is you can now create canned response handlers in a very easy fashion. They always return a certain response, and that can be really great for testing. Then the method handler else allows you to kind of custom tailor certain request handle logic. It dispatches exchanges to handlers based on the request method, for example, get or post, and it can help you complement existing handlers with canned response handlers, for example. Then this filter adapt request method is great for inspecting the request state and then adapting it based on that. So for example, you might want to change the method, or in this last bullet point, you might want to add a header to all incoming requests for edge cases or some testing case. Yeah, and then so these are the more obvious use cases for the API. There are some less obvious ones, but still interesting, that I want to show you on the last slide. So in this case, this is pulled from an article I wrote a while ago. It's called Working with a Simple Web Server API, and it examines some less obvious but interesting use cases of the simple web server. I will touch on this rather briefly. If you do want to dive into it a bit more deeply, I recommend you check out the article that I have linked on the last slide for you to have a look. So the first use case here is that you can create an in-memory file server. So there are cases where, let's say you are doing some testing, it might be better to steer clear from actual file system manipulation. And instead, you only want to work with in-memory resources. You don't want to create and then later clean up the file system, or create resources and then clean up the file system again. So the good thing is that the simple web server can help you with this. The file handler that is used by the server supports non-default file system paths. That means the only requirement is that the path that you give the handler implements the Java NIO file API. There are file systems out there that do that, and Google's Java in-memory file system is one of them. It's called JIMFS, or Java in-memory file system. And that means that you can create in-memory resources, so some files, some directories, and serve them with a simple web server. The advantage here is that you're not actually doing any file system manipulation, and that it's a runtime only solution. Once the program is stopped, there's no more file system resources cleanup to be done. So that's quite neat. The next use case is you can serve a zip file system. So in this case, the path of the zip file system's root entry is passed to the simple web server. Again, there's scenarios where that might come in handy. And then lastly, you can also serve a Java runtime directory. There are times where you might want to inspect the class files of the runtime image of a remote system. So let's say for diagnosability. And you can do this now by starting a simple web server that serves the modules directory of the given runtime image. This modules directory contains one subdirectory for each module in the image, and accordingly, it contains files for the loaded classes. To access this directory programmatically, you load the JRT file system and then use that to inspect the directory and retrieve the class files at runtime. So yeah, as I said, these are three kind of less obvious but more interesting use cases. And if you do want to dive deeper into that, I recommend you check out the article. You can see here, I added a few links for the API documentation. You can also check out the jwebserver's man page. I added a link to the JEP 408 for you to have a look. And then the last one here is this article that I mentioned. And with this, I thank you for listening. And yeah, let me know if you have any questions. I'm looking forward to discussing the simple web server further with you. And if you have any feedback, here are my contact details. I'm always happy to hear from people using it or have any comments or feedback around it. Thank you.